Hello everyone, welcome to the session where we'll be covering how to tune Oracle Analytics for natural language. In today's session, we'll be covering a few tips and tricks, as well as some undocumented capabilities of the Oracle Analytics suite. My name is Jacques Vigeant. I'm product manager responsible for all things search and mobile, natural language processing, as well as natural language generation. So what we wanted to do today was walk you through exactly how Ask in Natural Language works and go through when you speak or ask a question and the time that you get a result. Because understanding each one of these steps will really help you sort of fine-tune the environment to get the results that you hope and expect. So let's get underway. So it all starts from a simple question. So whether you're on the home page in day by day or even via a chatbot in the future. Suppose you have a simple question like, what are the top 5 streamed songs by artists in 2017? So if you're on a mobile device, actually the first step is voice recognition. We need to listen to the sound waves and turn that into text before OAC can actually do anything meaningful. Now, in this particular step, Oracle actually gets out of the way. We believe that Google Voice SDK and Android does a fantastic job of natural language or voice recognition, we should say. Siri and the Apple Voice Kit does a great job on iOS devices, and even the Microsoft Voice Recognition SDK on your Windows Surface device as well. So in this particular step, we will be as good or as bad as the recognition on your device. Where we start doing some of the interesting steps is actually once we have the text string. So this is where OAC really starts doing some intelligence in order to decode your sentence into interesting analytics. So the very first thing we have to do is actually identify which data set to sort of apply your question against. Now, there's lots of competitors out there who first ask you, to identify the data set and then ask a question. Now, if Google had taken that approach years ago, imagine they would ask you to first bring up the website and then enter a search string. That makes absolutely no sense. So the first thing we do is we use what we call our best fit algorithm to identify which of the dozens or hundreds of data sets in your system is the most likely one to have the answer to your song. So we'll, in this instance, look at, the words in your sentence like streams and songs and artists and compare that against, your sales data set, your supply chain, your HR, whatever you've got in your system. And then in this instance, we'd automatically discover that the Spotify data set is the most likely candidate to have the answer to your question. So now we move on to the next step is once we've identified the data set, we're going to actually start processing your sentence. And the first thing we need to do is sort of get rid of the noise in the sentence. So for example, in this sentence, you've got like what are the and by and in. Those are useful words, but ultimately it's kind of noise to the analytic sort of process. And so we get rid of the noise. And then the next thing we do is we find the meaningful bits in your sentence. So here there's a really interesting bit, top 5, so we can relate that in analytic terms to an expression. You've got words like streamed and artists. We can relate that back to measures and attributes in the Spotify dataset. And then 2017, well, 2017 is a year. Believe it or not, the word song in this sentence doesn't have a match in my Spotify dataset. And what's interesting is this is a real data set that we obtained from Spotify. And if I look at the data in the Spotify data set, I've got country and date, and I've got artists. I've got something that they call track name. I've got number of streams, emotion, and so forth. And so some of these things are really easy. So artists matches artist and streams, number of streams. But this song thing, actually, through the use of synonyms, can be related back to track name. So the 5th step in our process is that we look for equivalencies. So orphaned words in your sentence, we look up synonyms for them and see if we can relate them back to the source data. And in this instance, we got song is the same as a track name. So the next thing we do, we've now got, artist, track name, and streams as part of the Spotify data set. We're going to turn that into a good old SQL statement, logical SQL, as we call it. We can identify the columns and the measures, the data set, of course, and the year filter in this instance. Now, from that, we actually get a data and results set, if you will. Now, based on the composition of your results set, we can then pick a visualization, right? Depending on the combinations of measures and attributes, the Ask engine will actually pick the most appropriate visualization. So in this instance, we have 2 attributes and 1 measure. So we're actually going to pick a stacked bar chart. But if it had been, across time, we probably would have used a line chart. Or if it had been very few dimension members, we might have picked a pie chart. So there's this whole set of rules that based on the data types that you're looking at, for example, geography, we would have picked a map. And the data composition, how many dimension members, based on those combinations of elements and dimensions, we will pick the appropriate chart type. So that's the process of actually going from, a spoken sentence all the way to a visualization that hopefully will help you answer the question that you had. So let's jump into the demo here. The first thing I'd like to show are some data prep tricks. So we have an entire capability of sort of enrichment and improving this raw data as you load it into the system. So now let's walk through a demo where I'll show you some of the data prep tricks when you're loading your data, how you can on the fly enrich it for natural language and really improve the potential result set. So here I've got a simple Spotify data set, which is an Excel file. I'm just going to drag it onto my home page here. A lot of people don't know that you can actually do that from your desktop, drag onto a home page. And here you can see I've got track name, I've got some artists, number of streams. It's really astonishing. You've got billions of streams here. It's really interesting to see how much people listen to the music here. And a whole slew of technical data and metadata to go through. So I'm going to go ahead and load that into Oracle Analytic Cloud. And so here's my data set. I'm going to go in now and open this data set to look at some data prep tricks that I can do and apply to this data set to improve my result. So the first thing I wanted to do is walk you through some of the recommended data enrichment things that you can do. So here I've got track name, that's fine, artist, number of streams, that's cool. I've got country here. And when you have to sort of think about the kinds of questions your user community are going to have. And are they going to search for specific countries? Yeah, sure, maybe, of course, really. But maybe they want to search across, North America or across continents. And we have the ability here on the fly in the data prep engine to actually create groups. So here I'm going to create just a really simple group. Of course, you would do more detailed groups here. But I'm going to create regions. And I'll do 2 simple regions. I'll do North America. And in North America, of course, you've got Canada. You've got Mexico. And then, of course, the United States. So I've created a group that is effectively a region that has Canada, Mexico, the US. And I'm going to create another group that I'm going to call the rest of the world. So that's cool. Go ahead and add that. So the benefit of doing that is now people can say, how many streams did Taylor Swift have in North America or in the rest of the world and so forth. Now date's an interesting one. Of course, date, I've got a raw, specific date, but people don't really ask for things at the date level. They would want to see maybe the number of songs by year. So I'm just going to go ahead and call that year. And they would probably want to see that, by month. There it is. And then I'm going to call that month. Now it's important to call these meaningful terms because users are going to ask for month using their voice. So by calling it the right thing, that'll work just fine. So that's an example of how on the fly, while you're loading your data, you're really improving it for natural language. So here you've got seasons, that's cool. You've got emotion. This is an interesting one. You've got a bunch of sort of rankings, if you will, or scoring in your data. Now, nobody would ever ask for danceability in terms of a number, right? They would ask for something more akin to, let's say, they would bin it, right? So they would say, okay, I would want, let's say, 2 bins, and these would be slow songs, and these, songs that I can dance to. All right, I'm gonna add that step. And then I'll do one more here. I'm gonna call that duration. I'm gonna call that duration description. And I'm gonna do, short, medium, and long songs. These are milliseconds, in case you're wondering. I'm going to add that. And so I could go on and on, but the point here is that you have to think about how people will access the data using their voice. It's not the same as where they have a visual environment where they might see the measures and drag and drop them onto a canvas or anything like that. So you have to think about how people will actually ask questions. So I'm going to go ahead and apply the script here. And so now my data has, these additional columns in them. So now the next thing you want to do, once you've sort of spruced up your data and made it a little bit more interesting, is you want to index it for search. So the way you do that is you go into the inspector here, and you go into the search area, and you decide column by column what you may or may not want to index. So by default, it will index all the metadata. And what we mean by metadata is it will allow you to ask about, in this instance, track name, duration, just the dates, the months, the years. But you might want to actually search for a specific artist, right? You might want to look for Ed Sheeran or Taylor Swift or, gosh, I'm so not hip. I can't think of a third one. But what we're going to do here is actually do a combination of the two. And in terms of best practices, it's important to only index meaningful things. Now, the kinds of things I don't want to index are things like keys, because keys are meaningless to most people, right? People don't think in terms of a song key. And so I'm going to go ahead and not index this sort of unnecessary data. But the idea here is you index only what you think people will search on, and then you go ahead and save that. And then you close. And then within the next few minutes, the indexing process will pick up this data set and index it for search. Now, while that's running, let's take a look at our best fit algorithm that I was talking about earlier. Now, not all data sets are created equal. And what I mean by that is, imagine a scenario where you had 3 or 4 data sets in your system or databases or whatever it is that your data is sourced to, and they may all have the same information in them. But, the revenue data set from your corporate IT system or folks is probably a higher quality data set than some little shared data set that you got as an email from, a coworker who was doing some modeling just for fun. And so we effectively rank the types of data sets based on whether it's a curated data model, which we consider the highest quality and therefore rank it the highest. And what we mean by curated data model, we're talking about the semantic layer, or people know them as the RPD, or also known as subject areas. We consider subject areas effectively the highest quality data that the Oracle Analytics system delivers to end users, because it's curated, it's verified by a team of IT, it's got security applied to it, and so we think that that's important to consider that when presenting the search results to users. The second ranking data set type is what we call certified data sets. So a certified data set needs to be certified by a BI administrator or Oracle Analytic administrator, and their name is actually tagged to the data set. So it'll say Jacques verified this data set and, signs his life that this data set is accurate. Therefore, if you find the data in here, you can ask Jacques why it's wrong specifically. So that's what the second ranking data set. The next sort of ranking is what we call personal data sets. So that's anything that you've uploaded, like my Spotify data set. I uploaded it, therefore, presumably I know the quality of the data. And if I index that for search, well, then we should probably consider that as a third ranking priority. And then finally, it's just a hodgepodge of data sets that your coworkers or colleagues may have shared with you, but wasn't necessarily certified by an IT administrator. So that's effectively the ranking order of data sets. And so let me show you what that looks like in our demo environment. And so for the sake of this demo, let me tell you a little bit about the data we've got in the system. Okay, we've got a subject area, a certified data set, a personal data set, and a shared data set in our demo environment, and I'll switch to that in a second. All of the data sets that we're going to search against have a revenue as a column in the data set. My sample app subject area has product, line of business, city, profit value, a column called profit value. I'm pointing that out for a specific reason. My certified data set has revenue also, but it's got salaries and wages. My personal data set has revenue and expense types and expense amount. And then this sample order lines has revenue and profit and product name and so forth. So now let me jump back into my environment here and show you how that manifests itself to the end user. So I was talking about how revenue is actually contained in each one of these data sets. So when I search on revenue here, you see that it's showing me 4 different revenues, and they're actually ranked by my sample app subject area, my personal data set, my sample order lines, and my certified data set. So you can see that we actually intelligently rank the data sets based on the quality of the data. Now, where it becomes interesting is if I do a combination of different terms. So for example, if I search for revenue and wages, okay, you'll see that it automatically selected a data set that had both revenue and wages. And in this instance, if I open in full screen, you can see that it was my certified data set because it had both those columns available. Now, if I had searched instead of revenue and wages, if I had searched for revenue by line of business, in this instance, it's going to pick, again, a completely different data set. And I can show you that that was the sample app data set. Now, where it becomes even more interesting is when you've got overlap. So I can say revenue and profit. And so now it's found a data set that had both revenue and profit, and that was my sample order lines, which is a shared data set. Now, the reason I wanted to show that one is to show that if I ask for revenue and profit by product now, the best fit algorithm will actually pick a completely different data set. And the explanation here, so if I go into the edit here, it actually picked sample app. And so why did this search actually yield your subject area as the appropriate data set? And the reason it did that is because both data sets had revenue, so that's fine. My sample order lines data set had a column called profit, and in this instance, I have a column called profit value. But where it became more interesting is that this one also had a third column that matched my query. I had product. And so given that this data set had the most overlap with my sentence, it went away from sample order lines to effectively my subject area. So again, you need to sort of try and think about all the overlap between the terms in your data sets. And you know, this requires some iteration and searching, trying different combinations of terms to make sure that you've set your indexing strategy correctly, but effectively, that's how the best fit algorithm works. So now let's go back to my data set, and hopefully the Spotify the Spotify data is now available for search. So I can search for number of streams. So we see that it actually loaded my Spotify data set. I can look for streams. I could look for artist. Whoops, artist. Sorry, artist. I could search for specific year or North America, right? And so you can see that these dimensions that I actually created on the fly from my source data are now available for search. I could look for slow songs, and I could keep going. I could look at this now also by track name, right? So now I'll see the streams by each artist. So we see that Ed Sheeran had 2 slow songs. DJ Snake had 1, and so forth. So that's the notion of enriching the data that you're indexing on the fly through data prep. Now, one thing that's kind of a shame is that I can't search for streams by song, right? It's a shame that I, you know, can't, oh, this is for slow songs, but I can't actually find the song column in my Spotify data set. And so the way we solve that is by allowing people to actually upload what we call synonyms. And so a synonyms, I've got one prepared here, is a simple text file that contains your, you know, source column like artists, and then a sequence of synonyms that match. So for example, an artist may be known as a singer or a songwriter, right? Track name, well, that's definitely a song. Emotion is, you know, show me list of songs by mood, not by emotion, or at least I think that way. And then number of streams, you might want to call that replays, or number of replays, or plays, or listens, or tracks listened, and so forth. So you can effectively just upload, just like any other data set, a set of name value pairs into the system. And then just like that, the next time your data set gets indexed here, and this is a little trick for you, you just go in and check it off again and save your data set again. And now next time the indexer, in a couple of minutes, it will pick up the synonyms file and apply it against your data set. So while that's running, let's take a quick look on some of the security considerations. And so a lot of people ask me, you know, how does it work? Is it secure? How do I set all this up? And some of the considerations that you have to think about. And as I was writing this slide, I was amused. I put less is more. And what I meant is not less security is better. But what I mean is you shouldn't index things that you don't think people are going to search on. And so be very careful to only index things that you know people are interested in, certainly from a natural language perspective. Now, from a more functional or role permission perspective, in order to search, your users need to at least have what we call the DV consumer role in the system, and they must also have access to the subject area. So if you've created a subject area but haven't given a specific user access to it, they won't be able to see or search for that data. How do you certify a data set? Only a BI administrator, a service administrator for those Oracle Analytic techies out there, can actually certify a data set. And as you certify a data set, we will annotate the data set saying that, Peter certified this data set on this date. Therefore, if there's a problem with that data, the people who discover the problem can go back to Peter and let him know that maybe he needs to uncertify that data set or update it or fix it or whatever the case calls for. And then last but not least, and it seems kind of obvious, but a user needs to have read access to a shared data set in order to be able to search it. So enough stalling. Let's go back to my home page now and see. So now we can actually ask for something like show streams by song. And so now you can see it found that streams by track name. And now if you combine everything together, I've added synonyms, I've done some on-the-fly data enrichments, I've done some date or some grouping of countries into regions. And now you can actually start asking some pretty interesting questions. And I'll finish on this one last question, which is show streams for the top 20 songs that I can dance to in North America. And so now you can see that it covered number of streams by track name for songs that have a danceability of I can dance to that in North America. And then you can keep going. You could ask for the top 20, long songs. And so now you can see the top 20 long songs, and I can even ask by artist. So that concludes what I wanted to walk you through today. Now, if I can leave you with 3 key things to remember is first, prepare your data with the mindset of how people will ask questions against it. The quality of your data will directly impact the quality of your results, of course. The second thing is, please only index the key things that users are interested in. There's this temptation to index everything for everyone, but the more you index, the more collisions and confusion the engine has to deal with, and the least likely the accuracy of the results will reflect that, I should say. And then lastly, use synonyms. People ask for the same thing different ways. Revenue, income, sales, those are all the same things. So please use synonyms to help the engine identify what the user means. So thank you very much for attending my session. Should you have any questions, please contact me in the info below.